We are going to be looking at enzymes. Now, you have been given an experiment, and the experiment or information is given here. The pupils in a science class were given equal masses of liver, which contains the enzyme catalase, and they were added to test tubes containing solutions incubated at 40 degrees of different pHs. Now, a foam was produced and the height was recorded. So that's the key thing about the experiment. Now, we now need to think about what are the variables that we have in this scenario. What we will change, what we will measure, and what we will keep the same. So it's essential that we pay keen attention to the details and how it is written. Now, enzymes usually break down large food particles into smaller molecules that can be absorbed into the blood. Essentially, they speed up digestion. Do experiments, we tend to keep a lot of things constant. Those are the control variable. So if we were doing something, what we keep constant here, for example, easiest is the mass. So the mass is kept constant. The temperature of the water bath is kept constant. All right, and the volume of the solutions used were kept constant. When we make reference to the mass here, it's the mass of the liver that was used. Okay, now when it comes down to independent variable, so independent variable again is something that we measure. No, it's something that we actually change, right? So make sure you pay attention to the key part. So independent is what we change. So from the experiment, we change pH, right? So we have different pHs, all right? And so the pH of the solutions okay, now when it comes down to the dependent variable, this is actually what we measure, and that would be the height of the foam. Okay. When it comes down to your results, we have to make some analysis. And you will come across the terminologies anomalies. Anomalies. So anomalies usually mean the odd one. All right. So if we, for instance, look at this line of results, we have 22.0, 10.5, and 21.2. These two values are close enough, whereas this one is extremely far off. So of course we identify this value and we strike it from our results. And this value is an anomaly. Now, when we do our average, we would not include our anomalous value. All right, so for example, let's just give an example here. When we do the average for this, it's 22 plus 21.2, then divide that by 2, so we end up with 21.6. Right? If we had included this value, we would get a different value from this. Okay, range, we now need to create a suitable graph. So the first thing is that we create a suitable graph with correct headings, scale, and accurate plotting of the mean average data from the table. We will then draw a trend line on the graph Be reminded that trend lines vary. Not all trend lines are the same. So sometimes you'll have straight lines that go through the origin. Then sometimes you have lines that are curved. All right, and sometimes you have lines that curve the other way. So the key thing is to know that trend lines vary based on the pattern of your results. The next thing is that you need to be able to describe the trends shown for the data, right? And in our experiment, we want you to be able to utilize the words substrate and active site. And we would have looked at some aspect of substrate and active sites in lesson. Let's take, for example, we have a substrate and an enzyme. So here we have an enzyme, and then here we have a substrate. Essentially, when a reaction takes place is that the enzyme binds to the substrate. It forms a enzyme substrate complex. Right? So essentially, here is the active site. And you'll notice that the substrate fits into it nicely. So enzymes and substrate work as lock and keys. So they have specific shapes, so they fit into each other. Drawing of a graph is quite essential and a lot of times seem to be very difficult for many. Now, when you draw a graph, you have two axes. You have the y-axis and the x-axis. The x-axis most and often all the times carries the independent variable. Whatever you are changing goes here. And on the y-axis, we have the dependent variable. So whatever we measure goes on this axis. The key thing is that you always want to make sure that you have a good scale. And we're going to look at that later on. But the key thing is that you need to have a big enough space graph that will span your results, right? So for instance, if your highest Y value is 90, you would want to go up to say 100, you know? Your graph might end here, but you need a space. Your independent variable, say the highest value is 10, you go up to 11, right? So make sure that your graph fall within that space. So you'll normally have your values and then you do your line of best fit. And most times when you're doing a line of best fit, you want to use a ruler, especially if it is a straight line. So you get your ruler and you draw a line of best fit, right? So the key things. Also, you may want to consider a very suitable title, right? So that's that. Now, when you're drawing your graphs, always essential that you use a pencil, because for instance, you make an error, you will want to be able to make corrections to the errors that you have made. Okay. If you're using pens, it's going to be very difficult. You'd have to start over each time. And sometimes students will mix the values around. So the dependent variables, sometimes you'll see them put it on the x-axis. That is wrong. If it's not on the y-axis, it's wrong. So just always make sure dependent on y, independent on x.